All right, welcome to the beginning of Chapter 7. This is the lecture associated with Section 7.1 of our textbook. It's an introduction to arrays. As is the case with my normal videos, I want to record something that will approximate what you would have in the classroom. So we're going to do warm-ups and exercises and give you the opportunity to pause the video and evaluate what you're seeing, work in your notebook, and then come back to the video. So we'll start today with a warm-up. The question is, what does the following method do? Does it have any preconditions? What would this method look like without using Scanner's next method? I'm going to go ahead and pause here for a moment, ask you to pause the video, give yourself some time to work through these commands, and then I will come back. All right, so the first question is, what does the following method do? Luckily, I did not name this method something mysterious like mystery or enigma. For once, we actually named our method what its purpose is, which is, of course, what we should always be doing. This method is called add three terms, and its job is to take a string, feed as a parameter, feed that string to a scanner, pull three tokens out of that scanner. We assume that those tokens are strings, which those strings are fed to the method parseInt, integer.parseInt, which converts them to an int, and then it prints out the sum of the first term, the second term, and the third term. So the idea is it takes a string that represents three numbers, adds them together, prints that to the console. Does it have any preconditions? Boy, you bet. If we were to try and pass a string that did not contain three tokens that could be converted to ints, we'd be in trouble. If they were doubles, if they were words, this would not work. So there are some preconditions with this method. What would this method look like without using Scanner's next method? I'm hoping we all saw that integer.parseInt was unnecessary, that we could just as easily say scan.nextInt and convert those tokens into ints. All right, so that's your warm-up. This is Introduction to Arrays based on Section 7.1 of your textbook. So the objective here is to define and create an array. We're going to talk about what that is. Decide when it is we're going to need an array. How do we get the size, or length is what we'll call it, of an array. And we want to be able to assign values to and retrieve values from an array. So as I typically like to frame new tools, let's talk about the kind of problem you might encounter that would call for an array. So suppose you'd been asked by the Washington State Department of Transportation to write a program to analyze rain patterns. They want to be able to enter values into a program and have it produce some statistics. So namely, one of the statistics they want is average rainfall. And how would we solve that problem? So we could do this with rainfall, we could do this with temperatures, but the idea is we want to produce some kind of weather metric. So I might have a program that we want it to run. We're going to say, hey, how many temperatures do you want me to read in? And say the number is 7. And then we would take in 7 values from the user, and boop, we would spit out an average, the average being 44.6, and away we go. We've done our job. We've served the Washington State Department of Transportation. The code might look something like this, and I would ask that you go ahead, pause the video again, take a look at what we have written out, compare it to the output you saw on the previous slide, and make sure that we understand what we're doing here. I'm going to pause, and then I will walk this code in just a moment. Okay. So looking at this code, it appears that the first thing that we do is we declare a scanner that's aimed at our user, system.in, and we ask how many days temperatures are we reading, and we get from our user a value that we store at the variable days. This is important because we got to know how many times to run our for loop to get temperatures from the user. We assume we don't want an infinite number of temperatures. So then we create a sum value, and we start our for loop from 0 up until the value of days, and then we print out, day value of I plus 1's high temperature is, and then They will input to the console a number which is stored at sum, and we keep adding to sum and adding to sum and adding to sum every time this for loop runs. And then we're able to determine an average by casting sum, which is an int, to a double, dividing it by days, so we've calculated average, and then we print that out to the user using handy dandy printf, saying give me 1 decimal place of precision. And that's the idea of how we might solve this problem. Pretty straightforward. We're familiar with scanners, we're familiar with loops, we're familiar with printf. So this seems like a problem that we could solve with our current tool set. Take a look at maybe a new problem, which is what if that Washington State Department of Transportation asked for how many days were above the average temperature? How many days were above the average temperature? Well, think about what that means. That would mean that as you are accumulating temperatures, you take in day 1, you take in day 2, you take in D3. Every time you take in a new temperature, if you were to pause in that moment and calculate the average would be changing constantly. And perhaps after 3 or 4 values in, temperature number 3 was above the average. But as we enter more and more values, it could be determined that it was no longer. So what we really need to do is we need to finish calculating average, and then we got to go back and look at our temperatures and see which ones were above the average. So this is a problem. Let's think about why this is. It really means that we need every value twice, right? Once for calculating the average and then once for comparing it to the average. How could we tackle this problem? Well, we could read each value in as a variable, but what if they want to enter in 10 numbers? What if they want to enter in 10,000 numbers? At some point it becomes unwieldy to declare that many variables. What we're really looking for here is a way to declare many variables in one step. We want to be able to group a bunch of variable values together. And the solution to that problem is an array. I would, if you have your notebook out, take a moment and copy down these 3 definitions I have in orange. I'll pause here for a second. All right, so that tool that we've been looking for, a way to record many values, to have many variables, it's called an array. And the idea is it's like a box, or really like a container that has many little subsections inside of it. And each one of those subsections is labeled with a location, or what we call an index, just like the string had an index. And in each index, in which each one of these little sub boxes is a value that we can put in there. So an array contains a bunch of individual components, a bunch of individual, we call them elements. And we know where the elements are based on their index. It's like the address on your house. It tells you where to look to get a value. Now what's important is, just like strings, arrays are 0 indexed, meaning that we consider the very first element of an array to live at location 0, to live at index 0. So the value of 12 is element 0. Over here, the value of 5 is element 4. Even though 5, as it turns out, is the 5th element in the array, if I wanted to access that element, I would ask for element index 4. We see that there are 10 values in this array, but the last possible index that we could access is not index 10, it is index 9. The reason for that is we started at 0 instead of 1, which is why the last value is 9. So that's an array. Syntax Yoda is here to tell you about the way to declare an array. Arrays can be a lot of different types. We can collect different ints, or doubles, or strings, or chars. And the way we do it, if we break down how each of these arrays is declared, is we see that each time we declare an array, we decide what its type will be. And then to communicate to Java that we're not talking about an individual int, but a group of ints, we use these angle brackets, or what some people call box brackets. And that communicates, it says, hey, look, I'm not talking about one int, I mean many ints. So we would have a type, some box brackets. We have an identifier, which often should reflect that we're talking about multiple of some type. So what would you call a bunch of ints? I might call them numbers. A bunch of doubles could be prices. A bunch of strings could be names. A bunch of chars could be letters. So we've got type, box bracket, identifier. We use that new keyword, which hopefully is a signal to you that an array is not a primitive data type, but a more complex type, like an object, right? And then we again repeat, what are we making a new of? We're making a new array of ints. And right here, the number that goes in the box brackets on this side is the length of the array. So we said that an array is a vessel for containing elements. We decide how many pockets, how many cubbies are in that vessel by determining the length. So if I said an array of int called numbers, give me a brand new one of an array of int of size 10, that means I could store 10 different values in the numbers array. I could store 20 different values in the prices array, 3 in names, 2 in letters, and so on and so forth. So let's talk about the property of an array called length. The size of an array can be any integer expression, obviously not negative integers. And we can define the size with a literal value, an expression, or a variable. Well, what does that mean? So here's an example of the most common way you're going to declare an array, which is you're just going to say, give me a collection of this type. I'm going to call it this. Give me a brand new one that has this many spots. But if you needed to, you could create an expression. It could be dependent on some variable value. Or maybe if you want to get from the user some value, you could just create an array of that size, right? So there's a lot of different ways we can decide what this number is, but we do ultimately give it a number to say, array, this is your length, this is how many spots you have. All right. Good. Okay, so let's say we have an array and we want to verify what its length is, how long it is, or perhaps there's some of our code that is dependent on its length. Arrays have something called a length field. So let's say I made an array of strings and it's to represent a deck of cards. I will give this array 52 locations, 52 places to put elements. Well, I could say system.out.println deckofcards.length, and that would print out the number 52. It prints out the length. I'm sure some of you are looking at this and thinking to yourself, wait a minute, where are the parentheses right here? Shouldn't there be parentheses? Because every time we use length with strings, we use parentheses, but with arrays, it turns out that we don't. So they both use the word length. In the case of string, it is a method that returns the length of the string. In the case of the array, it is just an inherent property. And when we declare the string, we say, this is your length. And something that we know about strings is that they are fixed. They cannot change in length. So that's why we just say dot length without the parentheses. Speaking of changing arrays, once it's been created, you cannot change the size. You could assign a brand new array to the identifier that you chose, but that doesn't change the size of an array to which you have already populated some elements. So what does that mean? Let's say I made an array called R, and it has a length of 6, and I decided to myself, you know what, 6 actually isn't enough. I would really like R to have a length of 9. You can do that. You can give a brand new array to the identifier R, but what that means is you've discarded any values you would initially put into array between these two statements. Those are now gone. So something to be mindful of. Arrays are good for storing multiple pieces of information, but they're not good about changing size. So let's talk about assigning and accessing array elements. What do we mean by that? I'm actually just going to show you a snippet of code here, and I'm going to ask you to pause, take a look at the code, and decide for yourself what it is you think this does. Make a prediction about what 3 values will be printed out. I'm going to wait here for a minute, and I'll come back. Okay, so what you're looking at is we go ahead and we declare a new array called numbers. It has a length of 5. And you might have guessed that when I say numbers bracket 0 bracket gets 2, that means that I'm taking the location that is index 0 and I'm assigning it this element. I'm assigning this value of 2. So now if I were to go look at my little chain of blocks, my little chain of boxes, I can see that 2 has been stored at location 0 and a 3 has been stored at location 1 at index of 1. And then this is how you assign a value. If you want to get a value, you just do what I've done right here, which is, hey, you know what? Go get me what is the value at index 0, add it to the value at index of 1. We'll add those together, and then we will assign that to location 2. So numbers of 2 should have a value of 5. So when I look down here and I print out numbers of 2, that should give me 5. But then when I go looking for numbers of 3, there's nothing in there yet. So I wonder what it's going to try and print out there. And then numbers of 5, well, this array has a length of 5, but it does not have an index of 5, right? The maximum allowable index is always going to be 1 less than the length. I have something at locations 0, 1, 2, 3, and 4, but I won't have something at 5. So let's see what happens. So as we predicted, printing out numbers of 2 gave us 5, and that makes sense. Numbers of 2 is the product of adding the index 0 and index 1 elements. It is important to note that if I were to change what is at index 0, or I would change what is at index of 1, it will not automatically update what is at index 2. I would have to reassign those values, just something to keep in mind. So numbers of 2 was 5, we knew that. Numbers of 3 is 0, which means something you should put down in your notes is that if I make an array of primitive data types, then it will be populated with a default value. What does that mean? Well, shortly after I created this int numbers of new ints, length of 5, if I were to look right there at what's stored at indexes 0, 1, 2, 3, and 4, it's all going to be the value of 0. And the reason for that is 0 is the default value for int. 0.0 is the default value for double. Oh golly, I think it is false is the default value for Boolean, and the empty char is the default value for a char. I am pretty confident on those last two, but the ones that are going to come up the most are int and double. So bear in mind that the default value in an array for int is 0 and for double is 0.0. All right, so boiling it down to the basic example of how you would do this, if I want to get a value, I say the name or the identifier of my array, use those box brackets and decide the index I want. If I'd like to assign or modify a value that's there, I could declare identifier index and assign the value. Again, we index at 0, so let's say I had declared an array called numbers. Numbers of 0 equals 27. Well, 27 is the element at location index 0. It's the first element. Numbers of 3 is -6. So if I were to say system.out.print line of numbers of 0, this will print out 27. If I want to access what's at location 3 to determine if it's less than 0, if it's negative, I could use a little bit of code like this. I could say, hey, you know what? If numbers of 3 is less than 0, print out element 3 is negative. In this case, it is. So that is how we access and modify our arrays. So let's revisit the problem. How do I, now that I have the ability to store all the values that I'm given by the Washington State Department of Transportation, what do? Well, I want to be able to say how many days do you want to put in for information, enter those days, determine the average, and then we want to be able to say that 4 were above the average, right? So 45 was, 48 was, 46 was, and 53 was. And the other 3 days were not. So let's take a look here. This is a dense slide. I'm going to pause again, and I'm going to give you a moment to look and see what I changed. Compare it to what was on the last slide. I'll come back in a moment. We'll walk this code. We'll break it down. Okay, so just like before, declared a scanner aimed at the user, prompt the user for some input, take a integer from the user, and then right away I'm going to initialize a new array. I'm going to call it temps because we're talking about temperatures, and I'm going to make it the size that the user gave me, right? The user said, I'm going to give you this many numbers. Well, let's make an array that's of that size so we can store each of those numbers. I need an average, which means I need to track a sum. And so what I'm going to do is I'm going to make a for loop that goes from 0 to days, because I'm going to get that many numbers. And I'm going to prompt the user. I'm going to say day number, the first time through it'll say 0 plus 1. So day 1. High temperature was. And then check out what I did with this code right here. I said, give me the array called temps, give me index I, and assign to that value the next number that the user gives me, console.nextInt. So temps of I first will be assign a value at location 0. Then the next time through the loop, because I is 1, we would assign a value at location 1, and so on and so forth. So I record the value in the temps array, but I also take the time, once it's recorded, I take that value and I add it to sum. So this is important. Sum is going to allow us to calculate the average, and temps of I, or I should say the temps array, is going to let us go back through all of our values in the array and determine which ones we're over. So we go through this process. We've added up the sum of all the temperatures, and then we calculate the average by dividing the sum, cast as a double, divided by the number of days. Okay, we're good there. Then we want to initialize a variable called count that's going to rack up, hey, how many of these days were above the average? And now I have to go through all the values I stored in the array. So I'm going to again make a for loop, starts I is 0, goes up until days. And every time I go through the loop, I want to check a new value. So I'm going to start out with, hey, array called temps, give me the index of I, which will start out as 0, so first time through the loop. What's the number in your first location? Was it greater than average? If it was, up the count. If not, we'll just skip this if block, come back again, update our I, and we'll try again. So we'll check what's at temps of 0, then what's at temps of 1, 2, 3, 4, 5, and in the case of our previous example, up through temps of 6. There were 7 days, so we can check the number that is at temps of 6. And here's how we report the result. The average temperature was this, and the count of the number of days that was above average was that. And that helps kind of solve our problem a little bit. There's a lot of ways to work with arrays, and I want to be clear that you can use an array as a parameter. It looks a little funny, but hopefully as soon as you see this, you should be thinking to yourself, whoa, hello world, that really looks like hello world. And it turns out that the main method that Java requires, public static void main string args, is because it's string angle bracket args, what you're saying is when you run the main method, you could pass an array of strings called args, which is short for arguments. So that's an example that we've already seen where an array is a parameter. But let's look at a really basic example. If I wanted to make an array called first element, and the Java first element was to receive, I make a method called first element whose job it is to receive an array of ints and just return the first element in that array, we can see this is how I declare that we're going to use an array. So you're probably thinking, wow, if I ever need to enter in a whole bunch of values in an array, it's really going to be a pain, right? Do I have to say array of 0 is this, an array of 1 is that, an array of 2 is this, an array of 3 is that? The good news is there's a shortcut, and this should definitely be in your notes. If I wanted to put just a bunch of numbers in right away, so I've got the first 6 digits of pi, well, rather than use 7 different Java statements to populate into lots of nums, I can just, all in one fell swoop, load these 6 numbers in, and now they're ready to be accessed, ready to be changed. So let's say I load up lots of nums with those values. Well, what's at lots of nums of 0 is 3. Lots of nums of 1 is a 1. Lots of nums of 2 is 4, and so on and so forth. So if I ask, if I ask what's at lots of num 0, the answer to that one is 3. And when I do these, I'll pause after and see if you can guess what the right one is, right? So here we go. Lots of num is 0 is 3. Lots of num of 1, I spoiled this one, is 1. Lots of num 5. All right, so we've got 0, 1, 2, 3, 4, 5. Ooh, it gives me the last element, right? So lots of nums has a length of 6 because it contains 6 elements. The last allowable index is index 5, which has an element 9 at its location. Lots of nums 100. Error. So we're asking what is at location 100? Well, we only have locations we have locations 0 through 5. We don't have an 100. This would be an indexing out of bounds error. This would crash our program. It's not a syntax error. I believe this will compile because Java is saying, oh, they're just accessing the array. This would be an example of a runtime error because we go to access the array, but we've picked a bad location that does not exist, so it crashes. Lots of nums -1. You may have guessed does not exist. There's nothing before index of 0. So that, again, would be an index out of bounds error. Lots of nums true. Just getting silly here. There is no index true. Lots of nums stop. So, again, we only pass ints as indices for locations here. And it's got to be a value that we have that is within the length of our array. That's the moral of that story. Okay, that is the end of this lesson, introducing arrays.